All right, let's dive right in. We're going to pull back the curtain on maybe the single most important building block in all of modern programming, the object. It's the secret sauce that makes pretty much every app you use actually work.
You ever wonder about that? How your favorite game, or any app for that matter, remembers your username, your high score, and your custom settings all at the same time? Well, it's not magic. The answer is a clever little digital container called an object. So what is an object really? The best way to think about it is like a digital filing cabinet. Seriously, it's just a container that's designed to hold all the related info and actions for one single thing, like a user, a product, or, like we're about to see, a teacher.
And here's what one looks like out in the wild. We've made a teacher object. Inside this little container, we've got two pieces of information, and we call these properties. We have a name, which is Disha, and experience, which is 10. See? It's just a simple, super organized package for everything about this one teacher.
Okay, but objects are for way more than just holding data. That's kind of boring. They are active, living parts of our apps. So let's see how we can make them actually do something.
The info inside an object is not set in stone. We can change it whenever we want. Right here, we're reaching into the teacher object, grabbing the experience property, and setting it to 11. And just like that, our digital teacher has a whole new year of experience. It's this ability to change that makes objects so useful.
This chart breaks it down perfectly. An object really has two main parts. You've got properties, those are the nouns. They describe what the object is, like its name or its experience level. And then you have methods, those are the verbs. They define what an object can do, like calculate a bonus or print its own details.
And this is where it gets really fun. We can literally attach functions directly to our objects. So here, by adding this print details function to our teacher, it's not just a generic function anymore. It's now a method. It's a specific action that this teacher object now knows how to do, all by itself.
So now that we can build these powerful little containers, let's talk about one of the most common ways we use them, as temporary data packages, just to shuttle information around our code.
Just imagine, we have a function that needs like 10 different pieces of info to do its job. Are you really going to list all 10 of those out one by one? I mean, you could, but your code would be a complete mess and impossible to read. There's got to be a better way, right?
Of course there is. And the solution is so clean. It's called an inline or anonymous object. Instead of trying to pass 10 different things, you just bundle them all up into a single object that you create right on the spot, and you pass that one package. It's organized, it's clean, and it's just so much easier to understand.
And what's really fascinating is the lifespan of these things. They are literally created in the moment for one specific purpose. The function uses the data it needs from the package, and then, poof! As soon as the function is done, the object is gone. It was never saved anywhere, it never had a name, so it just disappears. It's the ultimate single-use tool.
So far, we've been building our objects by hand, one at a time. But what if you need thousands of them, like an object for every single user in your app? You're not going to type them all out. You need a pattern. You need a blueprint.
In this quote from the source material absolutely nails it. A class is a blueprint for an object. It's the perfect way to think about it. The blueprint isn't the house itself, right? It's the set of instructions for building the house. In the exact same way, a class is the set of instructions for building identical, consistent objects over and over again.
Now, this is a really important distinction to make. There are kind of two ways to define a pattern for an object. A type is like a contract or a quality inspector. Its only job is to check your object and make sure it has the right shape. But a class is the factory itself. It's the thing that actually creates new objects from the blueprint.
This table makes that difference crystal clear. A type's purpose is to define a shape. A class's purpose is to be a blueprint for creation. You use a type to check your code's structure, but you use a class to actually create new things while the code is running. So one is a checker and the other is a creator. It's as simple as that.
Okay, so we've covered what objects are, how to make them, how to use them, but let's zoom out for a minute. Why does any of this really matter? What's the big picture here?
Well, it all comes down to these 4 superpowers. First, organization. They keep your code from becoming a tangled nightmare. Second, real-world modeling. They let you build digital versions of complex things, like a user, a product, you name it. Third, reusability. Those blueprints, classes, let you just stamp out as many consistent objects as you need. And finally, clarity.
Code written with objects is just plain easier for other humans to read and understand. At the end of the day, objects aren't just a programming feature. They're a whole way of thinking. So the next time you log into an app, just for a second, try to picture it. That little user object working behind the scenes, holding all of your information in its own neat, tidy digital filing cabinet.